Hey everyone, it's Miss Lopez. In this video, I'm going to break down the Calvin cycle for you. Now, the Calvin cycle is also known as the light-independent reactions of photosynthesis. This is because this process, this biochemical pathway, does not depend on sunlight. So let's get started. First, as the name implies, this is a cycle. So much like the Krebs cycle, we are going to represent or scaffold this biochemical pathway with a large circle. I'm going to indicate the quote-unquote beginning of this cycle here at the top. Because it is a cycle, we are going to end up regenerating the ending molecule, just like we did with the Krebs cycle, when at the end of the Krebs cycle, we had to reform that oxaloacetate. Now, it's very, very important that you all understand that the products of the light-dependent reactions that we had talked about previously are needed for the light-independent reactions. And the two products that we are going to need are ATP and the NADPH. And again, these are coming from the light-dependent reactions. So one last ingredient we are going to need for the Calvin cycle is carbon dioxide, which is a small nonpolar gas, which means that it can simply diffuse across the membrane of the chloroplast. These reactions, the Calvin cycle, are taking place in the stroma of the chloroplast. Now, in this reaction, carbon dioxide is going to enter the Calvin cycle, and it's going to be joined with a molecule called RUBP. So RUBP is the end product of the Calvin cycle. In this process, carbon dioxide, which is a gas, will be joined by RUBP, which is a molecule. It is a organic molecule. And it's an enzyme that's going to join these two substrates together. As with the previous biochemical pathways that we talked about, it's important that you know that an enzyme is making this possible, but you don't need to know the name of the enzyme. However, just as a fun fact, this enzyme is called ribulose 1,5-bisphosphate carboxylate oxygenase, commonly known as Rubisco. So if you want to impress all your friends at your next social gathering when it's safe, you can impress them with that fun fact. So to help us understand the Calvin cycle a little bit better, we are going to divide it into 3 phases. And we're going to focus just on the important overall big concept of what you need to get out of these phases. So in this first phase, when we are taking carbon dioxide gas and attaching it to an organic molecule, and again, this is done by enzymes, this first part is known as your carbon fixation phase. Because fixation in science means when we take a gas, any gas, and attach it to an organic molecule. The enzyme takes this 2-substrate, carbon dioxide gas and RUBP, and joins them together to form a product. And that product will become the substrate for the next part or the next enzyme in this biochemical pathway. And that's all we're going to learn about the Calvin cycle. We don't need to know the structure of the enzymes or the structure of the product or the substrates, just that in the carbon fixation phase, we're going to take that carbon dioxide gas and attach it to an organic molecule. The next phase of the Calvin cycle is called the reduction phase. Now, it's called the reduction phase because the substrates in this part of the Calvin cycle are going to be reduced. And remember, reduced means that they're gaining those electrons. Now, this portion of the Calvin cycle not only requires electrons, it's also going to require ATP. So ATP will phosphorylate the substrates in the reduction phase. And NADPH will donate its electrons to those substrates. Now, many students will get confused because in this process, NADPH is being oxidized to NADP+. but it's termed the reduction phase because the substrates are being reduced. And you can't have reduction without oxidation. So as the substrate is being reduced, the NADPH is being oxidized. Now, at the end of the reduction phase, you are going to have an organic molecule, some kind of output. But keep in mind that in order to start the next turn of the Calvin cycle, we are going to need to remake or regenerate the RUBP that we started with over here in this area. So we cannot take the organic molecule that we have right here and use it to completely make a glucose molecule, which we know is the, in our equation, the end product of photosynthesis. So we can't jump immediately and make that glucose. We are going to make a starter for the glucose, but we're also going to need to go back and remake this RUBP to start the next turn of the Calvin cycle. And that last phase is known as the regeneration of RUBP. And this process requires ATP as well. So ATP will phosphorylate the substrates of this portion of that biochemical pathway in order to get the RUBP needed to start the next turn of the Calvin cycle. So this is a very generic drawing of the Calvin cycle. And what you do need to know is that it does require ATP in the reduction phase and in the regeneration of RUBP. And it's also going to require the electrons from that NADPH, and those were produced in the light-dependent reaction. Eventually, after the Calvin cycle has turned numerous times, eventually you are going to make glucose. And so it will take multiple turns of this Calvin cycle and multiple molecules of CO2 to eventually create a glucose molecule. Depending on your textbook and depending on what source you're looking on the internet, you may see various numbers placed here for the NADPH, the ATP, and the amount of CO2 and the number of turns. All of that is dependent on what that final organic molecule that is made, whether it's going to be that initial molecule or eventually become the glucose, depends on the number of turns the Calvin cycle has undergone. So for every time that a CO2 is added, keep in mind that it's not going straight into making glucose. You have to regenerate that RUBP, and so you're not going to get an exact one turn of the Calvin cycle will produce one turn of glucose. You're going to have to turn the Calvin cycle many times. I believe it's six times in total to fix 6 CO2 eventually to make that glucose molecule. And so that means that the amount of ATP and NADPH are also going to change. But we're just going to keep it simple, and we're not going to worry about the numbers, and just say as overall general process that the CO2 is fixed in that carbon fixation phase to this organic molecule, producing a product, and then that product is going to undergo, again, a biochemical pathway controlled by enzymes in the reduction phase, where we're going to input energy in the form of ATP, and we're going to input electrons in the form of NADPH. Then some of that molecule will be used to eventually make an organic molecule in glucose, but we are going to need to regenerate the next molecule of RUBP. That's going to require additional energy, and so that phase is known as the regeneration of RUBP. I hope this video was helpful for you guys. Thanks so much for watching.